Hello friends, in this video we are going to discuss example based on convolution sum for infinite sequences signal. Therefore, let us assume the example as where x of n is equal to 1 by 2 raised to n u of n and h of n is equal to 1 by 3 raised to n u of n minus 1. So if we want to find out the convolution sum, and if we try to solve this particular example using graphical method, we won't be able to get appropriate answer because these sequences are approaching towards infinity. Therefore, we cannot get a finite answer. Similarly, if we go with analytical approach also, the limits of summation will be infinite and it is not possible to find out the summation with the infinite limit. Therefore, the solution for this particular example goes in this way. So first of all, let us represent the equation for convolution sum. If we see the original equation for convolution sum, it is given as y of n is equal to summation k equal to minus infinity to plus infinity x of k into h of n minus k. So in this approach, from the given equations, we need to find out x of k and h of n minus k. So let us see how to solve this example. So the first condition is we need to find out x of k. So from given equation we have x of n is equal to 1 by 2 raised to n into u of n. So represent or replace n with k. So we get x of k is equal to 1 by 2 raised to k into u of k. As we all know that u of k is nothing but unit step signal. So this unit step signal has value equal to 1 for k greater than equal to 1, k greater than equal to 0, and 0 for k less than 0. So if we substitute this value in above equation, we get x of k is equal to 1 by 2 raised to k into 1 for k greater than or equal to 0. And if we substitute 0 for the other part, the entire answer becomes 0. Therefore, x of k is equal to 1 by 2 raised to k for the condition k greater than equal to 0. Similarly, go for the second case, find out h of n minus k. From the original equation, h of n is 1 by 3 raised to n into u of n minus 1. It is 1 by 3 raised to n into u of n minus 1. So first of all, replace n with n minus k. So h of n minus k is equal to 1 by 3 raised to n minus k into u of n minus k minus 1. Now if we simplify this equation, so 1 by 3 raised to n minus k will be as it is. Now we need to find out the representation of u of n minus k minus 1. Here this u of n minus k minus 1 is nothing but the shifted version of unit step signal. So if you find out this u of n minus k minus 1 signal, if you draw it, this signal will have amplitude 1 for k less than equal to n minus 1. So you can draw it and you can cross check this limit. Here k is less than equal to n minus 1. Now this is what the required representations, that in the base equation of convolution sum we want x of k and h of n minus k. So we have obtained these equations with the corresponding limits of k. So in first case, if you look at in first case, we get the limit of k as k is greater than 0. So this forms the lower limit of our summation, that the values of k should be greater than 0. And in second case, we get k is less than n minus 1. So the values of k are less, so it represents the upper limit. Therefore, we can now find out the convolution sum, which is y of n equal to summation k equal to minus infinity to plus infinity x of k into h of n minus k. Here these limits will be replaced now. So the limits of k are from 0 to n minus 1. The value of x of k is 1 by 2 raised to k from the first part. The value of h of n minus k is 1 by 3 raised to n minus k. Now simplify this summation. One by 2 raised to k will be as it is into 1 by 3 raised to n into, we are going to separate out these terms, 1 by 3 raised to minus k. So 1 by 3 raised to n can be taken out of summation because this summation is with respect to k. So it becomes now 1 by 3 raised to n summation k equal to 0 to n minus 1, 1 by 2 raised to k into 1 by 3 raised to minus k. So again simplify this equation. So here 1 by 2 as it is, 1 by 3 raised to minus k will be simply 3 raised to k. So now here both the terms 1 by 2 and 3 are with the power of k, so we can combine this term together. And now it becomes 3 by 2 raised to k. To solve this particular summation, we have an identity, summation identity, that summation, let's say n equal to n1 to n2 a raised to n. So this identity is represented in two parts. First part is if the value of a is not equal to 1, and the second is if the value of a is equal to 1. So for the first part, a is not equal to 1, it is given as a raised to n1 minus a raised to n2 plus 1 divided by 1 minus a. And for the second part, it is n2 minus n1 plus 1. So in our case, here a is not equal to 1, so we will be using the first part. So our equation becomes 1 by 3 raised to n. A is 3 by 2 raised to n1. In our case, n1 is 0 minus 3 by 2 raised to n2. n2 is our n minus 1 plus 1 divided by 1 minus a, which is again 3 by 2. So simplify this part. 1 by 3 raised to n, inside this bracket 3 by 2 raised to 0 is 1, minus 3 by 2 raised to, so n minus 1 plus 1 gets cancelled out, so simply it is 3 by 2 raised to n upon, so if you simplify this, so 2 minus 3 divided by 2, so it becomes minus 1 by 2. Now take this denominator out, so it becomes minus 2 into, so if I multiply this 1 by 3 raised to n inside, so I'll get 1 by 3 raised to n minus 1 by 3 raised to n into 3 by 2 raised to n. So again we can combine these two brackets because the power of these two brackets are n. And the final answer we are going to get is minus 2 into first term will be 1 by 3 raised to n minus, if you merge these terms together, 3 will be cancelled out and we will get simply 1 by 2 raised to n. So this will be our y of n. So this is how we are going to solve the equations for infinite sequences.